All right, so here we go. We do have adding and subtracting on this. And like I said, we'll start by stating our excluded values. Remember, the excluded values are anything that's going to cause our denominator to equal 0. Well, now in this case, it's actually the same number. We could take the time to set up two different ones, 5x not equal to 0 and 4x not equal to 0. But what I have to tell you is this: if you ever have an x in the denominator without a plus or minus sign, that excluded value is 0. It is 0. So we have an excluded value of 0 here. Excuse me. Now at this point, you could go one of two methods on this. One method that people like to do is they like to come over here and write a common denominator. Now the common denominator of these things, you can prime factor these things out. But the first number that these two numbers meet at, that's 4x and 5x, we have to get them to the common denominator of 20x. Got to get them to the common denominator of 20x. That is the smallest number that both of these go into. So what we ask ourselves is, how do we get each of these numbers to that amount? And what you do is you give them what the other one has that it does not. All right, you'll hear me talk about this. I've got 4 kids, but I've got 2 little boys right there. You know, what you give to one, you got to give to the other. All right. So if they both have that thing, I don't have to give that. So they both have x's, so I don't have to give x's. This side, and again, like I said, you could prime factor these out, and we'll do that later on possibly. But for now, we're just going to make these values have a common denominator. The way I do that on the left side is I multiply times 4 over 4. Think about that mathematically. What is 4 divided by 4 equal? And I multiply times 1. What happens when you multiply times 1? It's the same thing, right? So I officially have not actually made a change to these values. So the whole what you do to one side, yet we don't have to worry about all that because I multiplied times 1. Now the right side has the 4, but it does not have the 5. And again, notice I'm paying no attention to the numerator. I could care less what the numerator does. So I keep moving on here. I'm going to change these values to where they match. So the numerator on the other side is 24. That's 6 times 4 over 20x. Plus 5 times 7 is 35 over 20x. Now please do not try to cancel these or you're going to get right back to where you were. But now we have that common denominator. And again, ask yourself, what does a fraction do? Does the denominator of a fraction change when you add them? No. So neither does a rational. So my rational, I'm going to move these down here. My rational denominator is 20x. And my numerator is 24 plus 35, which is 59. So my simplified form of this is 59 over 20x. Now, if you'll notice, delta math, that's level 1, right? So don't get too excited. I'm glad if you got that. That's great with a monomial. But we got to look a little further. Now, what we need to do as well is make sure that these numbers do not reduce. 59 is a prime number, so 20 does not go into it. So this is the simplest form. All right. And by the way, you can get common denominators by dividing just like by multiplying. That doesn't happen often, but when you do run into that, I would take advantage. So let's take a look at the next. So here you see, this is where we start running into some issues. Let's do this first of all. Let's state our excluded values. From the left parentheses, x cannot be equal to 3. From the right denominator, x cannot be equal to 5. I would suggest always doing that, especially if you got a multiple choice test. I've seen multiple choice tests where that information is enough to have the answer. And I don't even have to do all the other stuff, which is really nice. All right, now, here we go. finding the common denominator. Here's the thing. These are binomials, and the entire binomials need to be accounted for. We need to bring everything that everybody wants. Like I said, I'm packing for a camping trip here. We got to bring everything that everybody wants. Well, the left side wants an x minus 3, so we're bringing an x minus 3. The right side wants an x minus 5, so we're bringing it. So this is our common denominator. I'm going to go ahead and go over here and write that. Our common denominator is x minus 3, x minus 5. That's what we're trying to get to. So now we got to discuss how we're going to get there. So what we do is we look at our little list down here. Okay, we need an x minus 3 and an x minus 5. Well, this one already has the x minus 3, so check that off of its list. It needs the x minus 5. And if you're thinking, well, is it just what the other one has? Most of the time, yes. So here's a key point, parentheses. If you aren't going to use parentheses, you're going to make several mistakes. Guys, we got a little timer running as we do this question. These questions take a long time, all right? So that's what the left side needs. And try to color coordinate this, see if it helps a little bit. So the right side has the x minus 5, but it needs the x minus 3. Top and bottom. Here's a pivotal point. I know it seems like a small thing. Here's the pivotal point. Put a parentheses around that. This is kind of like an Algebra 1 final. You're going to factor, well, you won't factor this one, but we'll distribute, combine like terms, a lot of stuff going on. All right, so here we go. I'm going to go ahead and put my plus sign down to split these two up. I'm going to erase this. Don't need this anymore because I already got my common denominator. So in green, 7 times x is 7x. 7 times negative 5 is negative 35. Now we have a FOIL going on in the top. How you do this is completely up to you. Here's how I'm going to do it. I'm going to take this thing down here, do the distribution method, and then bring the result back up to the top. And the reason why I'm doing that is just to save a little bit of space as we're doing this. So 3 times x is 3x squared. 3 times negative 3 is negative 9x. 1 times x is positive x. 1 times negative 3 is negative 3. So my combining like terms, which in this case is only these two, is that. Now what? Simplify. Just the numerator. By the way, the denominator does this a lot. The denominator just kind of tags along as we're going through this thing. Now, if this would have been a minus sign right here, this makes this question a lot harder. Because if this was a minus sign, remember, I would end up having to distribute a negative 1, right? Be careful of that. It's not, so I don't have to, so let's just combine our like terms. So 3x squared doesn't have any like terms. There it is. I have 8x negative, or 7x and negative 8x, which is negative x. And then negative 35 and negative 3 is negative 38. I'm going to be lazy. I've now got to check to make sure that the numerator doesn't, and really, I know better. We'll talk about it in just a second, but I'm going to just show you what I'm doing. I'm going to graph and see if the 3x cubed, crosses the x-axis at any important parts. So I'll do that real quick. Minus x, minus 38. Crossing at two irrational numbers, so that's good news. But I already had a good idea of this, because think about this. Everybody pay close attention, because this will save you a lot of time. 38, the reason why we would factor is to cancel. All right? The reason why we would factor is to cancel. Well, the only numbers that are going to cancel are numbers that have a 3 or a 5 in it. Do either of these numbers go into 38? No. So even if this would have worked out, and it didn't cancel, what we would end up doing is putting them back. All right? All right, so now, somebody want to take the, be the guinea pig and put that one in Delta Math? All right, somebody wait and see if it's also going to take this answer, which is what you're going to see on your ACT. What you're going to see on your ACT is the distribution of these two numbers. Remember, they add up to make the middle, and they multiply to be the end. These are both sufficient answers. No one is better than the other. Would somebody else want to put that one in for me? Anybody want to verify that that one works too? Because they're the same answer. They're the same answer. What's the difference? You're going to see this one on your ACT, where you distribute them back. Here's the good news. You know what I'm going to say already. You can graph these. If you were to graph y1 equals all of this stuff, and y2 equals either of these two, they will have exactly the same table. Exactly. Their errors will even be the same. All right. All right. As we look at this one, let's stop and think for a moment. Are these common denominators? No. So what can we do? We could multiply times the other one's denominators, but always stop and think. Think what we can do. And if you really do your process in the right order, your excluded values are going to clue you in as well, because watch this. There's one excluded value. X cannot be equal 8. What about when I set up the other one? Watch this. That's the same thing, isn't it? Which means they are actually the same fraction. The same factors. So we just got to see how we make them factor. So what do you think we can do on this one? Throw me some ideas, even if it just, I'll tell you if it will work. You're not necessarily saying that you think it's going to work. Just give me some ideas. What do you think we could possibly do? What might we do on this? One is to do this. Multiply times the other one's denominator. If nobody speaks up, I'm going to make y'all do that. And trust me, that's not what you want to do. You could do this. You ain't going to like it. So give me some alternate ideas that we could do. Anybody want me to do something first? I'm about to make you guys do it the hard way. Y'all won't give me some ideas. Why both sides? You're close. Really, really close. Yep. And which side makes sense? I agree. Y'all, everybody understand what he's saying? If he said multiply both sides by negative, and all you really did was move the problem to the other side. So we multiply the 1. Let me rewrite this for some of you, and I think this will clarify, that's a word, clarify some things for you. What if we put the negative x in front and the 8 in back? I think that might help a few of you see what is actually happening here. Now, he said multiply times -1, which is perfectly fine. Here's another way. Factor out -1. Because what happens when you factor out a -1? Everything's signs change, right? So here's what this would look like. Negative x minus 8. The x would change to positive, the 8 would change to negative. Any ideas on that? Or any questions? Let's put it that way. Nobody has a step. Ask me a question. Yeah.
So, but I thought you have to do the same thing with the other fraction.
But I didn't change anything yet, did I? And that's on the either side of equal signs. Remember, what we got to do to one side, we have to do to the other. This one, I'm just basically rearranging and I'm rewriting it another way. Any ideas or any questions? We got a funny looking thing happening here. If you look, what have we talked about? Negative in the denominator. Uncommon, not wrong, it's uncommon. So let me ask you a question. Can I move that negative somewhere else? Where else can I move it? Any of them. It can be any of the 3 positions. I just can't have it at multiple positions. So think about that. I can put it at the top, I can put it in front, or I can put it in bottom. Where would it be a good place to put it? Why is that? Everybody catch that? By factoring out that negative and moving it to the front, I've now turned it to this. That's right. They basically said, if you were to think about it, what they basically gave us was 1/2 minus 1 over -2. Same thing, right? So let's talk about adding fractions, though. Let's think. Let's not step away from what we're doing here. What part changes? What parts don't? Numerator is the math that we're talking about. 1 + 1, 2. What happens to the denominator? Stays the same. That would have gotten really, really ugly had we multiplied times the other one's denominators. You still could have gotten to the answer, but it would have been really, really ugly. All right? So always stop and think. Always stop and think about what these are. This is also another opportunity where many of you might want to start the thing by graphing. You know, take a look when we start getting to solving these things. All right, let's move along. That took a little bit of time, so okay. What do you think we got to do first? We can't yet. Even before that, she said common denominator. Every time you get to these, and let me give you another huge hint. You ready? There is no math rule for this, but this is just math teacher that loves them some shortcuts. If you see something on the left side, you're going to see it on the right side. Almost willing to bet you. All right? So the factors are x, yeah, you're right. Threw me off. I was writing. So x minus 6x. What I'm writing, not what I'm saying. Yeah, there we go. All right, so here we go. That is just a rewrite. There are no value changes there. Let's go ahead and state our excluded values down here. X equals -6, X equals 7, right? And I say equal. Remember, it's not equals. So let's think about our denominator wish list. You ready for the denominator wish list? Here it is. I wish for, it's like Christmas time, right? Here's Santa list over on the other side. I want an x minus 6 or x plus 6. The one on the right says, I want an x plus 6. Okay, there it is. Don't write it twice. Nobody wants two of them, right? They all want one, so I'm going to give one. And we also need an x minus 7. That's the wish list. Okay, so wish list, what does the right side need that it does not have? The left side. It needs the x minus 7. What's the right one need? This is what you were saying, like you were ahead of me.
7.
The right one needs nothing. The right one has everything on the list. It has the x plus 6. It has the x minus 7. So leave it alone. All right? Like we talked about yesterday, the sleeping baby, right? Whoops. Don't wake a sleeping baby. That one has exactly what it wants. Leave it alone. Here's what I do. This is just my habit. I think it's a good habit. I come over here and write that common denominator before I lose it. Last thing I want to do is lose my common denominator. So go over there and write it before it goes away. Left side, we have some distribution. 7x minus 49 plus x. So this one's shaping up not to be too very bad, right? Numerator, everything's together, but we do have 7 and x and 1x. You are correct. Thank you. This would be minus x. So 7 minus x would be 6x over x plus 6, x minus 7. Is the numerator factor at all? 49 only has 7, so no. So let me show you this. Now it's time for history class, not math class. Do not distribute this. Why would I say that? Because you don't need to do a math lesson here. You have to take a history lesson. Didn't you just factor to get those numbers? So take the history lesson and go back and rewrite what it was. We're not, whoa, don't know what that's all about. Yeah. So I guess I'm getting started. There we go. So we have x. And by the way, the answer that I'm leaving behind is correct. If you put that in Delta Math, it would be correct as well. But I like to show it this way because that's what your ACT will look like. Both answers should work. Can I get a confirmation on that? Okay. And then the last one. That one only took like 5 minutes. You guys tell me. What's this one missing? Denominator. It actually does have a denominator. It's got one of them invisible ones, doesn't it? So we have this. If you want to rewrite it, you can, but I'm not going to. But I am going to do a state my only excluded value. X cannot be 5. What about the 1? That 1 cannot become a 0 by plugging in an x. It's not possible. Got to have a variable to do that. So let's put our list of things we need. A 1, which we are never going to write because what's 1 times 1 equal?
1.
Anything times 1 stays alone, right? So this one is not contributing anything. It does, however, need something. What does it need?
What does what mean?
The left side. It needs the x minus 5.
Wow.
So we're going to give it the, let's do this in green. We'll give it the x minus 5 top and bottom. Because remember, that is not changing values. I essentially multiplied times 1. gets a little messy because you do get a lot of foiling, and it is foiling because it's 2 by 2. I don't care if you do it up here or you take a detour like I like to do. I like to come down here and take a detour. The disadvantage of the detour is I have made mistakes copying it back up into the answer. But there's always chances of making mistakes anywhere you go. X times 7 is 7x. Negative 25x. Negative 35. Got two like terms here, so now I'll rewrite. My common denominator is x minus 5, by the way. And if you do this, you're not wrong. You just wasted a little bit of your time, and that's okay. So my numerator becomes 5x squared. Let's do this in a different color. Green, I think, is what I stuck to. I wrote it in blue down there, but minus 2x. So here's what we got. We might have something cooking here because think about this. The top is ending in 35, isn't it? And 5 can go into that. So this is a possibility. But does anybody notice something else about the numerator? Notice something else about those three numbers? We cannot cancel it because it's an equal sign, but we can factor a 5. So this would be 5x squared. Now, some of you are going to be able to tell me the answer to this right away. Are there factors of 7 that can become 4? No. So if I'm not going to be able to factor that thing, leave it alone. And secondly, if a 5 couldn't have gone into it, we would have been wasting our time anyway. But it was worth a look. Now, we actually have 2 correct answers here. This is a correct answer. We had to do that to make sure that nothing canceled. But also, this is a correct answer. The delta math is probably going to want what I highlighted in yellow, but it should take both. If it's not, we might have made, and I say we, I might have made a mistake. Is it not taking that answer? It doesn't take the one in black? Takes the one in yellow, but not. On the bottom one? You mean the numerator? Yeah, this.